Okay, so this type of notation can be very confusing for a lot of students. So I want to walk through what this notation means. We're saying we have a function g of x, and it's equal to this other function f of x, except there's some transformations happening. We're plugging in x plus 3. We're multiplying the function by -2, and we're adding 4. So the first thing to do here is just think about, no matter what f is, what are these transformations going to do? So if we look at the x plus 3, right, we say that's going to shift. It's going to shift 3 units to the left. And then if we look at the plus 4, right, it's going to shift 4 units up. And then the -2 is going to flip it vertically. All the outputs are going to be multiplied by a negative, which is going to flip the graph vertically. And then it's going to become 2 times steeper. Okay, 2 times steeper. So before we even look at what f of x is, we know what's happening to f of x, because that's what this notation is telling us. It's telling us how f of x is being transformed. So what we can do is look at a couple different options of f of x and see how this transformation is going to affect it. So here we have a couple options. Now don't forget, we said that f is going to be shifted 3 units to the left, multiplied by -2, and then we're going to add 4. We talked about how that will show up graphically. Now really quick, another way to think about this x plus 3 that's in here is that it's just the new input. So instead of writing x, we're going to write x plus 3. We've done this before. You know that if we say f of something, whatever that something is the input. So that means we're going to replace x with x plus 3, because that is our new input. That's going right there. Right there is where x plus 3 is going. So what we end up writing is f of x equals, okay, what's x minus 7? X plus 3 minus 7. So we have x plus 3 is replacing x, still subtracting 7, right? Well, that's going to be x minus 4. Now think about it this way. If you were to look at just a good old x cubed function, right? Well, this is the x cubed function shifted 7 units to the right. We said this was 3 left, right? So if we say 3 left versus 7 right, 3 left, 7 right, that combines to 4 right, which is what we got when we plugged this in. So that's another way to think about it. Now, if we do -2 times -3, that gets us a final result of a 6 out front. And then we're just going to add 4. Oh, and then, sorry, this is still a cubic graph. Okay, so we have 6 times x minus 4 cubed plus 4. Okay, let's look at this other possibility of f of x. Again, we're going to plug in x plus 3 for x, which is going to give us a total of x plus 5. Again, another way of thinking about it, we're shifting 3 units to the left, right? It was already shifted 2 units left. So 3 units left, 2 units left, that's going to be a combo of 5 units left. So we're going to end up with square root x plus 5. All right. The outputs were already multiplied by 1/2, and now we're multiplying the outputs by -2. So that's going to combine for a -1. And then we're shifting it 4 units up still, so let's shift it 4 units up. Okay, there we go. There's our final, and I guess, we should say these are g of x, right? That's what g of x is, not f of x, sorry. G of x. Because g of x is the function transformed. Okay, I'm going to pull up a couple graphs so we can look at the graphs really quick. Okay, so here we have the graphs, and we can see that both, so the reds are the originals, which you should be able to figure out, but they've both been shifted to the left 3, okay, from 7 to 4, and then up 4, right? The left 3 and up 4. They're both flipped vertically, so you can see that, right? Look at where the end behavior of the red graph versus the blue graph, and then here we see the blue is flipped vertically. And then they're both 2 times steeper, which is a little bit tough to see, but if we compared the average rate of change, the rise over run, right, we would see that they're actually 2 times steeper at every single point. So what's happened is, this was our original transformation again, right? 3 left, up 4, multiplied by -2, and we've seen how this notation could be applied to any graph that we define as f of x. In this case, we looked at two different potential options, and we can see how that transformation would affect those two options graphically.